We're ready for our next section. So in this lesson, we're going to go over section 1, 2, measuring and constructing segments. Now I have here that we need a compass and a straight edge today. We are actually going to go past that and not use the compass and straight edge, so you'll be okay. Okay, so make sure you have your notes out and let's get started on our lesson today. Okay, so our objectives. Use length and midpoint of a segment, and we won't be doing this part here where we're constructing midpoints and congruent segments. We're going to leave the construction parts of the geometry class till towards the end, so we'll skip through this today. And your vocabulary that we'll go over. Take a look. Got lots of different vocabulary words today to review. Some of these you'll be aware of, and some will be new. Okay, let's start with our first vocabulary word. A ruler can be used to measure the distance between 2 points. A point corresponds to one and only one number on a ruler. The number is called a coordinate. Okay, just like on our coordinate planes when we locate a point, same thing with the ruler. Okay, we're just doing it in one dimension, whereas a coordinate plane has 2 dimensions. The ruler postulate. Now, some of these postulates we go through are going to seem very basic, intuitively very intuitive, I guess. And just bear with them. You need those. We need them to be able to construct beyond the basics of geometry. So the ruler postulate is 1, 2, 1. It says the points on a line can be put into a one-to-one correspondence with real numbers, meaning I can line this ruler up in with 2 points, and those points are going to correspond to 2 numbers on my ruler. In this case, it might be 1.5, and this might be 5. Okay, so that's the ruler postulate. Okay. The distance between any 2 points is and I want to point this out, is the absolute value. Okay, absolute value has no sign. Oops. Has no sign. Okay, or some people will say it's always positive. Okay, it's the absolute value of the difference of the coordinates. If the coordinates of point A and B are renamed as values A and B, those are algebraic variables, then the distance between those 2 points is, and these bars are called absolute value bars. Okay, if you remember that from your algebra class. And you can write it in either direction, A minus B or B minus A, because the absolute value, it's measuring distance from 0. Let's put that. Absolute value, okay, measures distance from 0, okay? The distance between A and B is also called the length, okay, the length of AB or AB. Okay, notice when I name it, I'm using a line, okay, above. This is just designating 2 points right here, okay? So distance between 2 points, this is really good to use right there. You may want to highlight that. So let's practice what we know so far. This is going to seem very simple. We want to find the length between 2 points. Okay, so if I want to find the length between B and C, this is not talking about line BC, it's just talking about the distance between points, okay? So BC, and then also find AC. Now, make sure that you're showing this work, jot it down. So, if I take a look at BC, I know that B, right, is at 1, C is at 3. So this represents the absolute value of B minus C. If I take 1 minus 3, we get a -2, but the absolute value of -2, distance from -2, that distance is 2 units. Okay, let's try the distance between AC. Okay, so AC, right? The -2 designates the position of A, and -3 designates, 3 designates the position of C, okay, that you can see here. So we'll do our math inside of here. -2 minus 3, we get -5. Okay, so -5, how far is -5 from 0? Well, it is 5 units. Okay, simple as that. Again, while you're learning, showing more work while you're learning is important. Okay, so get that work down. Okay, let's try another one here. And again, you see I'm telling you, right here, show your work. Okay, this is practice time. Show that work with these notes. So the distance between X and Y. Okay, now X is partway between 1 and 2. So we're going to label it as 1 and 1/2. Some of you may prefer to use decimals, 1.5, and I'm okay with that. Okay, just as long as you're showing this work. So if I do the math, 1.5 minus 5, that I'll bet is -3.5. So the distance from 0 for -3.5 is just 3.5 units. Okay. Let's look at XZ. So again, X is at 1 and 1/2. Right here. This time, Z is at -3. Okay, so when we're finding distance, right, you can write it this way, X minus Z. Okay, Z itself is at -3. I'll have some students that will want to write this like so. 1 and 1/2 minus 3. That is not correct. Okay? So we'll do our math here. And I'm fine if you use a calculator. Find out what 1 and 1/2 minus a -3 is. Okay, that gives us 4 and 1/2. Okay, so the absolute value of 4 and 1/2 is just 4 and 1/2. Make sure as we're going through this, through our notes, that you jot down questions that you may have, highlight things that where you struggled, and bring them to class. First part of class, we'll always go over questions that you have had over the lessons, okay? Moving on. Okay, another vocabulary word, congruent segments, are segments that have the same length. You might want to highlight this part right here or circle it. Okay, congruent segments. So in our diagram, PQ and RS, okay, they are equal. PQ equals RS. PQ equals RS. So we can write, now this is an algebraic statement here. Okay, I'm gonna write that. PQ and RS are actually a geometric variable. Okay, so this is our algebraic equation, okay, using shorthand there. That's our algebraic equation. This here, where we have the lines above our points, PQ and RS, this is called a geometric, we'll put geo equation. There we go. Geometric equation. Okay. They are different. Okay. And we read this as saying, this is read as segment PQ, line segment PQ, no arrows, is congruent to segment RS. Okay? Congruent means same size and shape. Let's write that here. Congruent, same size and shape. Okay? Now something useful in geometry are these things right here. These little lines. They designate that they are congruent, and we call them tick marks. Okay, tick marks are used to show congruent segments. Okay, so another vocabulary word there for you. All right. You can make a sketch or measure and draw a segment. They may not be exact, but we call this a construction. It's a way of creating a figure that is more precise. Okay. Now this is the part that we are actually going to push off for right now. I'm not going to include this. You're going to need to see the next few slides, and I'm going to actually put X's through those because we're not going to do them right now. You're welcome to do that on your notes if you'd like. So we are going to skip example 2. All of these slides that are in your notes, we're going to skip these for right now. And we will save those for another day. Okay? Lucky for you, get to skip through some of your notes. We're actually going to skip this video for now. And all this will be saved for another time. Okay. Next part of this lesson, in constructing and measuring segments, we have another vocabulary word to start with. It says, in order for you to say that a point B is, get that here, is between 2 points A and C, all 3 points have to be on the same line. That is stated in postulate 122, segment addition postulate. Let's take a look at that. That is in your notes. We're going to use that coming up here. So, example 3a, G is between F and H. We know the length of FG. We know the length of FH. We're going to try to figure out their total length. Now, in geometry, this is also important. Drawing pictures, even if they're not perfect. Just draw a quick picture. Now, we skipped over the construction piece. That doesn't mean we're not going to still draw a line. So, first thing we know is that G is between F and H. So if I were to draw a picture of this, we're going to say F is here, H down here. We'll put a line between them, and we know that G is somewhere in the middle. It may not be perfect in terms of lengths, but that gives me something to look at. So the total of FH is equal to the sum of FG and GH. Okay, so we're going to use that segment addition postulate here first, then we'll substitute in our values. Okay, and now it's simple algebra. I want to find out what is this geometric variable equal to. So we'll subtract 6 from both sides, simplify it, and we know that GH is 5 units. Okay. Keep moving. Let's try another one. Now this one's already drawn for us, which is great. We don't have to do the drawing. It's actually labeled for us also, which is also important in geometry. Make sure when you do your drawings, you do labeling as well. Okay, we know that M is between N and O. There's N and O with M between them. We actually have some expressions for those lengths. Okay, now we're going to start with the segment addition postulate. After we do our drawing, we know that N plus M, that NM plus MO, right here, is equal to the full length NO. That's our segment addition postulate. Next, we're going to substitute in values that we know, and these can be expressions. So for NM, we know it's 17, MO, 3x minus 5, and on the other side, NO, the full length is 5x plus 2. Now we're going to go back to algebra. We're going to simplify this. So on the left-hand side, notice these two constants can be combined. 17 and a negative 5 combine into 12. Now, from here, you may choose what you want to move around. And there's lots of different choices to still get the same answer. I'm going to subtract the 2 from both sides. Okay. This is just one method. When I simplify that, notice I still have x terms on both sides of the equal sign. I want to get those on the same side, so we'll actually subtract the 3x from both sides, which leaves us with 10 equal to 2x. And you know that in order to separate these two, I have to divide by -2. Or sorry, divide by 2, not -2. When I do that, divide 2 from both sides, we find out that x is 5 units. Okay? Now, if it was asking us for the lengths of all these, right, and I find out what the variable is equal to, I have to remember to go back and plug that variable in, right, to those two expressions to find their lengths. Good work. Again, jot your questions down, bring them to class with you. Okay. Now that we know that what x equals, which is exactly what I was just talking about, where we substitute the variable back in, we know that x is equal to 2. We're going to substitute that in. Sorry, x is equal to 5. I apologize. X is equal to 5. And we just do the math. So NO, this entire length, is 27 units.